Okay, good day everybody, and welcome along to Week 8, Talk 2 on Programming Fundamentals on the Higher Diploma in Computer Science. Last couple of days we've had a little bit of issues getting started on the streams. Just had to restart the stream there, so apologies for the slight delay. Okay, but you can keep me informed in Slack if there's any problems in the future. Okay, so let's get started by asking everybody to just sign in Slack if you're taking part. If you've given us a reply to the, let's put one in there now, live now. Just give us a thumbs up in Slack, please, so we know who I'm dealing with. Okay, cool. So this week we are working on, actually, let's change that. Just change here for 1 second. Back to here. Yep, that's fine. So we're going to be developing our shop application further from one product to a number of products. That's what we're doing this week, and we started that process the last day using an array with shop version 2. You might remember we're now using classes, so we have the notion of a driver class and a product class from version 1, and then in version 2 we introduced this array of products and a field called number of products, which would keep track of how many products were in our shop or store. And the class that's going to handle all of this is store. But one of the issues that we had with using an array is you need to know in advance how many items you're going to be using up, and you can't go over that maximum amount. So there's a better way of doing things, and that's using the Java collection framework, which we introduced the last day. And specifically this week, we're working with one element of that collection framework called the array list. So today is about shop version 3. We're going to be refactoring shop version 2 to use an array list instead of an array, and we're going to see how that works. So on your web page for this week, on the left hand side here, you can see we have the talk from the last day, materials to go with the last class, and then now that it's working, today's class, which you can get at from here, and then underneath the notes to go with today's class and the lab. Okay. In relation to array lists, it has come up on the forums a couple of times in the last week. We gave out your assignment. We're halfway through the assignment right now, and we're still looking at array lists. And that's why I don't want you actually using array lists in your game. We want you to use the materials that you've covered up to and including Pong. We don't want you to use any further data structures like array lists. They will be coming up in your next assignment, and you'll have plenty of time to show off your use of array list in the next assignment. What I want you to do is to keep things simple, focus on what we've learned up to the end of week 6, so that you don't go down any blind alleys. Okay. It also helps us in restricting what you can do, helps us to alleviate any plagiarism in the assignments. So while you may be able to get a game that you like from the internet, you may find that it uses data structures that we're not allowing in this assignment. And it's a good idea to restrict yourself from time to time, work with what you have and work with what you know to the best of your ability. Okay. So I'm going to get straight into it then. Let's just put this up for 1 second. Just clearing a few things out here. So today we're going to be continuing with grouping of objects. We're working with our array list and iteration, which we started the last day. Here's our table of contents for the entire week. You can see we started with grouping objects, developing a basic personal notebook project using collections. Then we moved into indexing within collections. We saw that with arrays, you have a straightforward index. It starts at 0, it goes up to max -1 or size -1, and we don't get involved in changing the indices and removing positions within the array. However, that's not the case with collections. With collections, they manage the size themselves. There's a whole lot of methods that we can look at, and array lists are one of those collections, and we got into looking in detail how to use them. With any collection, you're going to want to visit each element in the collection from time to time, and we saw that iteration was a way of doing that. Just like with arrays, we used loops, for loops and while loops and do loops. But we introduced something new the last day, and that was called the for each loop. And I thought we might just start where we finished the last day. So these are some of the key slides from the last class. We saw that we had to import the ArrayList package from the Java util, or the ArrayList class from the Java utils package. We also saw that we have a declaration then of an array list of type string. Here the variable is called notes, and it's an array list, and the array list takes in a parameter, and that parameter is in angle brackets, and you specify the type of each element within the collection. So this is an array list. Notes is an array list of string. And then that's the declaration. We might want to initialize that, and here's how we initialize it. Our notes variable from above here we can see is then used when we go to initialize, and we're saying notes is assigned a value a new array list of string, and you'll notice the brackets, and the brackets means that it's going to call the constructor in order to set up that array list of string. Okay, so maybe what we might do is just ask you a question then. Let's see if Socrative is up and running. Let's have a look. No, still stopping me getting in this morning. Oh, here we go. That's better. So I'm going to switch to programming prog fundamentals. Prog fund is the name of the room, which you can see up here. And let's do a short answer. If you're having trouble getting into the room, I didn't have time since the last class actually to sort out the leading zeros. So if you look at your student number and there's a leading 0, it may be that you just need to not include the 0, okay, in order to be able to log in. So we've got on screen we have a way of declaring and initializing an array list of string. What I'd like you to do next is to actually combine those two lines to both declare and initialize the array list of string in one line. Let's see if you can have a go at doing that for me. So declare and initialize an array list of string. And to help, I'll just switch back to here. So just like when you were declaring variables, we have this way of both doing the declaration and the initialization on one line. I just want to see that you can do that for a collection. So the declaration will be on the left-hand side of an assignment statement, and the initialization will be the right-hand side of the assignment operator. Okay, let's take a look. Let's try this first one. Apologies. I think I removed one rather than show it there. Let's take a look. So we have private, array list, string, notes, good, is assigned a value, new array list, and then string, and then the brackets. So you can see everybody has typed that exactly the same. So that's great stuff. You know what we're doing. That's how we combine the declaration and the initialization. Well done, everybody. Okay. So array list, again, from the last day, we saw we had various methods that we can call in our array list. And these include the size, remove, add, clear, and get. So, for example, if we want to find out how many items are in our array list, we would call the name of the array list, for example, notes.size, and that would tell us how many items are in it. If we wanted to remove one, we can call the remove method and specify the index. Specify the element, and then the array list we can add by giving a new item to be added to the list. We can also clear the list, and then get is how we get back a specific item from that array list. So these are the main methods you would use with an array list. And then just before the end of class, we got to for each, and for each is a new way of looping, and you notice that the each keyword is not included in the for statement. So we've had for and while, we also have for each, and the way we read it is, if we take a look at this statement here, this notation was only introduced the last day, and the way you read this is for each note, notice the single note here, which is of type string, in the notes collection, and there's a colon between those, and that's how you effectively get the each. For each note of type string in the notes collection, print out the note. Okay, so I would say that that line is particularly important. This bit here. Okay, this is particularly important to remember. This is how we use for each, and notice the colon and the lack of the each keyword. It's for each note of type string in the notes collection, print out the note. Okay, so I'm going to give you another little exercise here. Let's switch back to Socrative. And I'm going to ask you to write up the for each loop, what that first line would be. Keep this up to make it a bit easier. And what I want to know is, for each oval in the shapes collection, how would you write that line? For each oval in the shapes collection, how would you write that code? probably left out something, haven't I? Yeah, probably need to give you a little bit more information on that. So it's for each oval of type circle in the shapes collection. So is this too hard? Do you want me to? Do you want more time? Just let us know on Slack if you want me to go over. No response. Okay. Hopefully you're still receiving us. So let's take a look at this. So what we said, for each oval of type circle in the shapes collection. Okay, so you already have the notes. These notes are up on your web page. So if you open up another tab, you should navigate to week 8, and if you click on the slides then for talk 2, you can have the notation in front of you. Thanks for that comment. So here's the 4. So that would be the answer to the question that we just posed. Okay. So the way you would read this again is, for each oval of type circle in the shapes collection. And that's how we read out what's in green. So is that okay? Can you indicate with a thumbs up or thumbs down? Oh, okay. Let me check. Yeah, I did have trouble with it this morning. Thanks for the heads up on Socrative. Okay, let's try. If it's not working, we can abandon it and just stick with Slack for today. I certainly had trouble with it this morning. Okay. Okay, well let's just abandon Socrative for the moment and switch back to using Slack. So can you post your answers then, please, to this question, because I want you to get used to writing it. Call it question 1, and if you can reply to question 1 in Slack with the question that we just posed, for each oval of type circle in the shapes. Oh, and JD Mac, Socrative has just filled it out. Maybe I spoke too soon. Okay, let's have a look. So if we go through these answers, for each oval of type circle in the shapes collection, so the first one's correct. Second one, you might want a capital C on your circle. It's an object type. And I think maybe this answer here was included before I qualified the question. Okay, yeah, both of these. So that's fine. Okay, thanks for that. I don't know what's going on that there was such a delay there, but let's see what happens on the next one maybe. Okay. So we're still on what we covered the last day, and you can see it's quite important that we cover this before we move on. So the array list collection, some summaries. We specify the type of collection, for example, notes, and the type of objects it will contain, for example, a string. And we say notes is an array list of string. Summary then. We have the Java collections framework from the last day. We were working on array list, and we need to import the class from the utils package. And then we have private array list string notes. So this is how we declare the notes variable to be an array list of string. The private then just means that you can only access it from within the class. Then we have notes is a new array list of string. This is how we initialize it. We're going to use the add method to add a new note. We use the size method to return how many notes are in the collection. We can use the get method to return a specific note, and then remove to remove a note from the collection. And then we've just gone through the for each iterator, visiting each note. So for each note of type string in the notes collection, we're printing out that note. Okay, which is spelt out for you there. Okay, so we're now ready for today's class, 25 minutes later. But I think it was important that we take time out to do that again. Maybe what I'll do is I'll just take a little breather for 5 minutes then. Luckily today we don't have loads and loads of slide decks, so we can take a breather at this stage. So if you have any questions, you can post them on Slack. Okay, let's start that up and switch over. Okay, so we're now going to move things on. Now that we've covered that theory on for each and also collections and array lists, we're going to take a look at our shop version 2 and move it on to version 3. So this is version 2 of the shop, and we have a driver which required some changes. The store is a new class from version 1, and then with no changes to the product class. Okay, and that's just saying the same thing again there. Okay, so the goal is to use an array list of products instead of an array. So remember, version 2 had an array, and we had to keep track of the number of products that were in the store. That was a field in version 2. With version 3, we want to get rid of the array and use an array list instead. And that's going to involve making changes then to any methods where we were accessing the array. It's also going to make some changes to the class. Okay, so driver is going to be refactored. Any changes to the store interface are going to be reflected in this class. Store also has to be refactored to include an array list of product from storing products in an array. And again, product won't have any changes this time out. So let's take a look at product. No changes, but this is what it looks like. We have the product class in IntelliJ. These are the fields. We had 4 of them. We had our constructor product method. We have the getters and the setters and the toString method. So we've been over these now 2 or 3 times at this stage, so we're not going to spend a lot of time going through all of this because there's no change. So again, product has 4 instance variables. Four fields. We also have the constructor. The constructor uses the data passed in the 4 parameters to update the instance fields, which you'll see here. And we're using the this keyword, which is name overloading. Classes getters for each instance field, because each instance field was private, and in order to be able to get at those, we need a method then to give ourselves access. So these are the getter methods. Each getter method has a return statement. Then we have the setters. This is how we change those fields. So there'll be an assignment statement with each of these. And then the class has a toString method to return a string containing a user-friendly representation of the object state. So remember, there's no print line in this. It's just building a big long string. And this is the toString method. And we call this method from the store class that we will construct over the next few slides. So let's take a look at store. The idea here with store, again, is to refactor to an array list of products from what was previously just an array. So here's our store. And you'll notice there's only one field. And that field is called products, which is an array list of product type. But we're missing a field, and the field that's gone now is called total. We have the constructor for store, which is a method, and then the additional methods we have add, list products, cheapest product, list the current products, the average product price, list the products above a price, and then to 2 decimal places. And we'll be invoking these methods in classes coming up in the coming weeks. Store is something we're going to be working on over a number of weeks. So the store class now has just one field called products, which is an array list of product. And my question is, why don't we have total anymore? I'm going to give Socrative one more go. Let's see if it updates quickly this time. And our question was, why don't we have total anymore? So why is total gone? Let's see if this responds a little bit quicker. That's a bit better. So I'll just come back to here. We're looking at the fields in the store class, and we notice in this version, because we're using an array list of product, total is no longer needed. But my question is, why is that? What did we learn the last day that will allow you to answer that question? Okay, thanks for your answers, guys. Let's take a look. Okay, good answer. I don't know. Fair enough. We'll explain it. Second one, because you can now use size to find the total number of items in the array list. Great. The array list size can change. That's correct. Total is gone as the array list doesn't have a limit. Yeah. So hopefully the person said, I don't know. You actually will understand, because this is probably the best answer. From this answer, it says, because you can now use the size method to find out the total number of items in the array list. Remember, although the words sound similar, we have an array and we previously, and we're now changing the array to use an array list, and this is a collection. And one of the nice things about using a collection is that it will tell you how big it is, and you can add and remove things to that collection, and it manages the size of the collection. So with arrays, we can't do that, and we have to keep track of how many items we're using. So for example, you could declare an array to be of size 100, but you might only fill 2 places in it. So you'd have to keep track of the number of items that were actually in that big sparse array. Okay. So I hope that clarifies it for everybody. The array list size can change, yes, but it's the size method that enables you to find out how big it is. Total is gone as the array list doesn't have a limit. Yes, but it's the size method. Okay, size method, which you don't have to program. It comes as part of the using the collection, and that's why you might want to use an array list, because it makes your life a little bit easier. Once you understand how they work, of course. Okay. Okay, thanks for that. So, declaring an array list of product. I highlighted these at the start of today's class. Note the syntax. We have to import java.util .arraylist, which we see here. We have inside our class store, we are declaring products to be an array list of product. And then down here we have the constructor for the store, which creates and initialize a new array list. Again, you'll notice we don't have any mention of a size or how big we want to make the array list. It starts empty, and then as you start adding to it, it starts creating and reserving the memory as needed. Okay, and then that size method tells you how big it is, and it gets managed. So this is how we import the array list class so we can use it. This declares an array list of product as a private instance variable, and this is calling the constructor of the array list class to build the ArrayList object. Okay, so these methods work on the ArrayList to add products, print out contents, and print out the cheapest product. So let's take a look at these three methods. The first one is add product. So I've used color coding here to try and it's very difficult to call out words when they're all the same but are very similar to know what we're actually referring to. So I've used color coding here to try and simplify that a little bit. So what we're doing here is we're going to add a product object. So the product object variable is in blue to an array list of product, which is in green. So we're going to call the add method. It takes in a product object variable, which is of type product, capital P, data type or class. So because it's a capital P, that means it's a class. So this is a variable of this type. Okay, so this is the variable, and this is the class or data type. So we're taking in this product variable, and then we're going to use that product variable here when we call the add method of the collection, which is the array list of products. Okay, so I know product is on the screen an awful lot there. Hopefully that explanation allows you to see the wood from the trees. So the red is the array list. It holds objects of this type. This is an object variable of type product that we want to add to the array list. Actually, my red explanation is incorrect there. Let me just go back and fix that for you straight away. Oh yeah, actually it is okay. So what we're saying is the array list holds objects of this type, and the type is the class product. Okay, this is an object variable of type product that we want to add to the array list. And then in green, this is the array list of products. The add method is a method that comes with the ArrayList class, i.e. collections. A lot going on there. You may need to take time to process that. Okay. So we're adding a product object to an array list of product. So here in the blue box, we see our class called store. Again, color coding the pink to represent the store. And inside this class, we have products, which is an array list of product. So here's our products variable, and we're saying it's an array list of product. We also have the store constructor method, which initializes the products variable. And then we have our add method, which takes in a product. This is what we've just gone through on the last page. And it's going to add the product that we've just taken in to the products collection. So next we have the printing out the contents. So we want to print out the contents. We're going to use list products. List products here, you can see, returns a string. So let's take a look at it. We have the list products method, which you can see just here, and we're defining how that works. So if the size of the products array list is 0, then we return the string no products to the driver class to be printed. And we implement that using this first box. If products.size equals 0, return the string no products. Strings, remember, in double quotes. Else, if there are products in the array list, we want to return a string containing the index number of each product and the product details. So let's step through that. So we have our else statement. We have the list of products is initially set up to be an empty string. This variable here, list of products, is also the name of the method. And we are using a loop, for loop. And what it's doing is it's going to visit every element in our collection. For int I is assigned to value 0, go to I less than products.size. So irrespective of how big or small the collection is, we're going to visit each element in this collection, and then we're going to build up this string using string concatenation. Remember, the plus equals is the same as saying list of products is assigned a value list of products plus, and then what comes on the right hand side of that, we're using the I. We're using a colon string, and then this is the clever bit. This is where we get whatever the current product that we're looking at in the collection is, added to the string, and we're adding a new line character at the end of it. So this is going to go around, and if we take a look at some sample output, we can see, for example, if we had a collection with 3 products in it, the index would go from 0 to 1 to 2, and it would say product description, whatever that product was. Bringing back, using our products.get method, it bring back all of the information that we need in order to be able to build up this string. Okay. So the important bit here is that we're using the array list collection, and we already saw the last day that there are size methods and get methods, and we're using those now inside our own code. We're writing the method list products, and we're using those 2 methods in order to be able to get at all the data. Okay. So onto the third method in the store class, and this is the cheapest product. Print out the cheapest one. So again, here's the product class. It has a private field called unit cost. It has a getter called get unit cost, which will tell you what that value of that field is. But we need an algorithm then for working out what the cheapest one is. So we want to find the smallest value in the list. So let's take a look at this algorithm. If the products have been added to the array list, then assume that the first product in the array list is the cheapest. Set a local variable to store this object. Okay, so we're going to test the size of the array list. If the size is greater than 0, then we know we have a product. Assume that the first product in the array list is the cheapest, so you're going to set some local variable to be that value. Then for all product objects in the array list, this is a loop. We're going to check if the current product cost is lower than the cost of the product object stored in the local variable. If it is lower, then we update the local variable to hold the current product object. Otherwise, we do nothing. Go back around the loop. So this is going to visit every single object in our collection, and it's going to perform that test, trying to find the one with the lowest value. Then it's going to return the name of the cheapest product. Once we finish the for loop, we get to the end of the for loop. That local variable is holding the product which has the lowest cost. So at that point, we can return the name of the cheapest product, i.e. print out the details for that specific object. So you'll notice that we're now back to the else part of the outer if statement. So let's go back up to the very top. We said if products have been added to the array list, then you want to do everything that we just did. But if you don't have any products in your array list, then you want to return a message indicating that no products exist. So that is the algorithm for finding the cheapest product. So what we're going to have to do now is take each of these steps and look at how we would write the code. Okay, so let's start with step 1. Actually, before I do, I do realize that it's a little bit heavier going today and there's not as much interactivity. So I'm going to just pause again because I don't want to just be reading out and explaining, going one way the whole time. It can get a bit monotonous. So I'm going to pause for a few minutes again at this stage, and then we'll come back and absorb the second part. Okay, let me put up some time on the clock. And let's take a breather for 5 minutes, and we'll come back and get into how we implement this code. Okay, folks, welcome back. Heavy going this morning. We're working through this algorithm, trying to find the cheapest product in our collection, and our collection is an array list of product. So we've moved things on quite a bit. We're now using classes, we're using objects, we're now using collections, and we're trying to build this application for a store. And we've just outlined an algorithm just before the break to cover how to find the cheapest product in a collection. What you see here is how you might write that in English. And now what we've got to do is take each one of these steps and write individual lines of code in order to implement it. And if you break the problem down into these sub-steps, then it's quite manageable. But trying to do it all in one go can be quite difficult. So I've tried to make it easier by using numbers. So 1, 1.1, 1.2, and then within that 1.2.1, within that again 1.2.1.1. What these numbers are indicating, the fact that I have 4 numbers here, is the number of tab stops that you might have in writing your code, how you will indent your code, and that's been a problem in the past when you've been writing. So those numbers are to help you figure out the logical level within this algorithm. We've also included color coding. So you'll notice that number 1 is in red, number 1.1 is in purple, 1.2 is in green, 1.2.1 is in blue, and then we have the orange 1.2.1. So we stepped through this just before the break. I thought you needed a couple of minutes just to get a rest from it. And what we're now going to do over the next half hour is we're going to take each of these sections. We're going to explore each of them and how we're going to write Java code to implement each of these bits. And we're going to do that as a series of questions or quizzes. And I think you'll find that you're going to be able to do this quite easily. Okay, so let's start with the first one. Step 1, we have working on the outer if statement. So we have an if statement. If products have been added to the array list, return the cheapest product, else return a message indicating that no product exists. So the fact here is we have an if statement. How do we write the code for this algorithm? So we've outlined an if statement in red. So that should be easy enough to convert into Java code. You can write if statements. You've seen those before. Just for ease, I'm going to switch to Slack, and I'm going to type in step 1. And I'd like you to just look at the details in here. If products have been added to the array list, so how do you know that a product has been added to an array list? What method could you call to find out that? And what value might it have? That will give you the condition that you need for your if statement. And I'd like you to have a go at answering that, please. And if you just reply to step 1 in Slack. And a minute should be enough. So I'm going to put a minute up on the clock. And let's start that off. So this time we're asking for your answer in Slack by replying to step 1. Okay, you should have managed to get that by now. Time up. Let's take a look. Thanks for your answers there. Let's take a look at the solution here. So the key part here was what's the condition? And the condition is products.size. And because it's a method, we have the brackets after the dot size. Sorry, I have the wrong screen up. Let's put this up. So if products.size does not equal 0, or you have if products.size is greater than 0, I think some of you came up with, that's fine as well. Either would work. Then return the cheapest product. Else return. So some of you missed the else part. Return no products are in the array list. Okay, because it's easy enough. We know that there's no products here, so we don't have to do any further calculation. We can just return a string that says, there's no products in this list. Okay, so well done. 2 of you got that right. Hopefully the rest of you will be able to see from this just how small the code is in each one of these steps, and that you already should know how to implement it. So we have our outer if statement, and then the next part was in our algorithm was to work on step 1.1. Assume that the first product in the array list is the cheapest, and I have in brackets here, set a local variable to store this object. Okay, so we're inside the true part of the if branch, and inside that branch what we want you to do is to set a local variable to store the first object in the array list of products. So again, this is step 2, and I'm going to just put up step 2 here, and I'd like you to have a go, please, at just answering that. Okay, how do we write the code for this step? So you only need to give me the part that's in purple, which is an assignment statement. Set a local variable to store the first product in the array list. Again, we'll give you about a minute to get this done. When you're answering these questions, don't be afraid to get it wrong. Would appreciate if you have a go, and even if it's only half right, that's better than not attempting it at all. So this one should be a bit easier. It's basically declaring and initializing a variable. So just to keep things tidy, I've in Slack put in a message in the programming channel called step 2, and if you just reply with your answer to that, please. I seem to be getting answers being sent by direct message and everything. If you wouldn't mind just putting them in step 2. Okay, that's great. Excellent. Okay, so let's take a look at it. So step 1.1, I probably should have called it rather than step 2. Okay, you know what I mean. If products.size does not equal 0, the purple bit is what we're looking for. So we have to declare some local variable. I call it cheapest product, and cheapest product, which you can see here, is of type product, and I'm initializing it using the assignment statement to be, and then we're calling the get method, and we're saying get the first item in the array list. So the first item would have an index of 0, so getting 0 from this array list called products, which we'd already used on the previous line, hence the products here. That's how we get back the first item, and then we're going to put that into this new variable called cheapest product. So let's see what you came up with. We've got product cheapest. Yep. Well done, Jessica. Almost right, Killian. Just the data type needs to change there, and you can't say product square bracket 0. That would be what you would use in an array. We want to use the get method in order to pull it back. Thanks, Dermot. Hopefully you can see the changes we need to make there now. And Niall, yeah, excellent, well done. Thanks for playing along, guys. I think you'll get more out of it this way. Okay, so working on the for loop next. So again, we're within the if statement, and all I want you to do is to focus on, we need to write a for loop. We're working on the for loop for step 1.2. So I'm going to put in again step 1. I'll label it right this time. Step 1.2 this is. And what I want you to do is to reply, please, with what's going on here. For all product objects in the array list, how would you write that for statement? Now, we actually asked you this question at the very start of class when we recapped on what we did the last day. We used a for each loop. We went back over that again. So this is an example of where you might use it. Or you could use a straight for loop. You can use either one. For all product objects in the array list, so you want to visit every single item in the array list, how would you write that statement? Again, answers please to step 1.2 in Slack. Reply to the thread. Just waiting on one more. Give it another few seconds. Okay, all good. I think we have all the answers in, so we can switch back here. Yeah, I think you all got the right answer there. Well done, everybody. Let's view it on screen. And again, we're looking at the green text here. For each product in the products array list of product. And we have an open and closing brace. So yeah, some of you left out the braces, but that's not the end of the world at this stage. The key bit was, were you able to write that green line? And we saw that at the start of class, we saw it at the end of the previous class, and now you're using it yourselves, writing your own code. Excellent, well done. So the text at the end here, I would say, when you go away from looking at your code, if you take a couple of weeks away and you come back to this, you won't actually be able to read this. So it's a good idea to write it out like I have at the bottom here, and this will enable you to be able to read your own code. People are going to struggle with that. So what I've done is on the next slide, I've again color coded each of those keywords to explain what each part of that statement is. So the red is the product, capital P. This is the type of the object that's stored in the array list. The blue, lowercase product. This is the reference to the current object we're looking at in the array list. So we iterate over each object in the array list. This reference would change to point to the next object and so on. And then the green, this is the array list of products. Okay, there's an S there. So hopefully that will enable you to read this when you revisit it in the coming weeks and make it a bit easier to follow. Okay, so we're on to the next step. So we've created the for loop in step 1.2, and then within that for statement, within your curly braces, we now have the next step, which is if the current product cost is lower than the cost of the product object stored in the local variable. Okay, that's all we're going to focus on. It's an if statement. How would you write if the current product cost is lower than the cost of the product object stored in the local variable? So your local variable is going to be one part of the if statement. You're going to be comparing it to something else. And I'd like to see how you have a go at answering that. So again, I'm going to set up 1.2.1. That's our step. And I'd like you to have a go, please, at writing the code for the blue text on screen. Reply to the thread, step 1.2.1. And let's give another minute on the clock. See how you get on. I'm racing you against time. Bang on time, Killian. Well done. This one seems to be causing a bit of trouble for some reason. It shouldn't be. It's just an if statement. Cheers, Dermot. No more takers. Okay. Let's have a look at it then. No, the last two in. Okay, everybody's in. Great stuff. Okay, so let's take a look at this code. So again, we're only focused on the blue part. Here we have if product.getUnitCost. Remember, we had a method in our products class that would give you the unit cost. If that's less than the cheapest product.getUnitCost. So we're comparing here, we're comparing the current product that you're looking at, get its unit cost, this is a getter method, to the cheapest product, which was the variable we set up here, getting its unit cost, and now we're just comparing two numbers. Okay, let's see how you got on with that. Yeah, some of you have gone ahead and filled in the next bit. That's great. Just the if statement is all we're looking for. Yeah, I think you all got that. Well done. Okay. So following on from that then is what happens in the true branch, which is step 1.2.1.1, update the local variable to hold the current product object. Okay, I'm not going to, well, we better be consistent. Let's get you to fill this one in. 1.2.11. That's the step. And if you could just reply with what the statement would be, please, to complete that. And we shouldn't need a minute for this one. Okay, so you're all along the right lines. We have all our answers in. Let's take a look. So cheapest product is assigned value product. Okay, so remember, we're using a for loop. We're visiting each product in the products collection. Hopefully you can see that. Yeah, so we have a for statement. We're visiting each product in the products collection. We've just tested the current product. If product.getUnitCost is less than the cheapest product.getUnitCost, so we know that product is the current one. Set the cheapest product to be the current one. Okay, that's all that's needed. Yeah. Okay, so everybody got the right answer there. Killian, on your previous step, you included both steps, so the previous one was incorrect, but this one is right. Okay, well done. So almost there. Let's take a look at 1.3. Return the name of the cheapest product. So again, if you take a look at our code, we've had a for statement that's now visited every single object in the array list, trying to find the cheapest one. When it found the cheapest one, it updated a local variable. So we're now ready to return. Once you finish that loop, the local variable will have, or will be storing, the cheapest product. So you want to return the name of the cheapest product. So that's, again, a single line of code. Let's get you to answer this. This is 1.3. And again, if you could reply to the thread, how would we implement that? So it's not returning the cheapest product, it's returning the name of the cheapest product. So that's a big hint. Take a look at your slide for the product to find out what the method name is in order to return the name of the cheapest product. Just waiting on one more. Okay, thanks for that. So let's take a look at it. We're going to return cheapest product, which was the variable that we had declared up here. So cheapest product dot get product name was the getter method from the product class. Okay, looking at your answers, they're all right, bar there's a capital R in return on one of your answers. It should be a lowercase. Okay, it's case sensitive, but otherwise spot on. Well done, everybody. So we've now implemented the algorithm that was very complicated before the break. Let's just go all the way back. Just bring it back to here. This was the big complicated algorithm that we were trying to implement using our collections, and we've stepped through each one of these statements and we've given you a solution, or you've come up with the solution. And by actually breaking down each of the steps in this complicated algorithm, you've actually stored you've solved a much more complicated overall problem rather than just the individual steps. When you can sort out all the individual steps, you end up solving the overall problem. So that's the point of an algorithm. The algorithm is a solution to solving some complicated problem. The algorithm involves many steps, and by solving each of the smaller steps, which are simpler problems, you end up solving the overall problem. So well done on that. So let's just get ahead to here. This is where we stopped. So a couple of more slides just to finish this out, and we'll be there. Okay. Predictive text, yeah. Okay. So the driver class. Let's look at driver. So we're going to refactor driver. Any changes to the store interface are reflected in this class. So here's the store. Notice the constructor for store. Previously our shop used an array and we needed to know how many products to store. Now that we are using an array list, we don't need to set the capacity, so our constructor call just becomes store equals new store. You might remember we had this field number of products, and again we've asked you about that during class today. Why don't we need it anymore? It's because we are using a collection, and the collection we're using is an array list, and it has a method for telling you the size of the collection, so you don't need to know that in advance. It grows as needed, and it can be reduced in size as needed. So next time we're going to add a menu system in the driver class, but right now the user has no control over whether they want to add, list, etc. So that will be later versions of the shop. So here's an example of the output of this program. See, how many products would you like to have in your store? And we say 3. And then it takes in the first one, product name, product code, unit cost, and whether it's in the production line or not. Then it does the same for the second one, does the same for the third one. And once it takes in 3 products, it then just lists them out. Okay. So, collections. They allow an arbitrary number of objects to be stored. They're implemented in Java's class libraries, which contain tried and tested collection classes. In Java, class libraries are called packages, and we've used the ArrayList class from the java.util package. Okay, so this week was all about Java's collections, and specifically the one we looked at this week is ArrayList. So ArrayList items may be added and removed. Each item has an index, and the index values may change if items are removed or further items are added. Main ArrayList methods are add, get, remove, and size, and we've used most of those today. ArrayList is parameterized or generic type. Okay, spot on time. That concludes today's class. Happy to take any questions on that, or any other questions that you might wish to pose. You can do so on Slack right now. But for today, that's it. Okay, and best of luck on your assignment. We're halfway through at this stage. You have another week and a half before you submit. Should say that next week is St. Patrick's Day, and we deliberately didn't schedule any classes in St. Patrick's week. It's a chance for you to complete your assignment. There won't be any new materials next week. And again, you might understand why I wasn't keen for you to use array lists in assignment 2, because we've only just completed it at this stage. You'd want to be doing the labs next, and I just don't think we should be using that for assignment 2. Okay, but you should be in a good place for using it on the next assignment. Okay, so if there's no questions, oh, hang on, there's one coming in. Methinks I can see somebody typing. I'll just hang on for that. No. Okay, so I think we'll call it a day then, and enjoy next week. Best of luck in your assignments. We'll talk to you the week after. Okay.